name's Robert French. You can see my email down there. If you guys have any questions, you're more than welcome to ask them at any time. We'll answer them as we go, or maybe jump onto them at the end if they're more detailed. But yeah, just shoot me any questions you have also to my email there down at the bottom. All right, let's get through this. All right, so let's talk about SOLIDWORKS CAM 2021. What's nice about SOLIDWORKS CAM, you all should have it. If you have a license of SOLIDWORKS on subscription, you have access to the SOLIDWORKS CAM software, right? It's included in every license of SOLIDWORKS. So another thing to make note of is this paragraph right here is it's powered by CAMWORKS. So anything we discuss here is obviously going to be in the CAMWORKS 2021 as well. Yeah, and that they're essentially the same software. It's just kind of packaging level is really the distinction here. SOLIDWORKS CAM is kind of the lower level versions, and as you upgrade to more functionality and the paid packages, that's when you kind of start using full-blown CAMWORKS. So let's talk about a few of the improvements here. So the first thing is we can now set a default post processor folder within the tech database. So if I jump in here, you can see under the settings tab in the tech database that we can now specify this folder location. So this is great for companies that have multiple users in different locations, different offices, right? You could link this to a online network folder, right? So everyone can be using the correct post processors, right? It makes them a little bit easier to manage. We also have new stock types within the software, and let's jump in and look at some of those right now. So we got this simple enough block here that we want to machine. And if we jump into our stock options, you're going to see a couple new icons in here, right? So we have our existing ones like the bounding box, extruded sketch, and other part files or other 3D file formats. But one of the nice new ones is what we call predefined bounding box. So it's not too much different than the original bounding box, except now we can come in here and specify. You know, I'll come in here and bump up some of these values a little bit, give ourselves a little bit of extra stock all the way around. So if that's a standard size you find yourself using pretty often, you can, it's something you cut off of your chop saw, your band saw, and it's a typical size you're using pretty often, then save that, right? So we can add it to the database, name it something, right? Override existing, a lot of these typical options we see for kind of saving to our database or saving to our intelligence here, overriding existing, and so on. So once that's created, it shows up in this drop-down list now. So when I move on to other parts and want to use that stock size again, it's just kind of one click away, right? So that's a pretty nice enhancement for one new stock type. If we jump onto this other part real quick, this part kind of looks like it belongs on a lathe, kind of looks like it belongs on a mill. Hard to say exactly, but it totally could be cut on a mill, right? All this work could be done on a mill, but you don't necessarily want to start with square stock. And in the past, if you're on a mill machine, right, even if you were starting with round stock, you'd have to go draw a circular sketch, use a specified distance, right? But now we have this cylindrical option, this icon here in our property manager. When I activate that, depending on which way your coordinate system's facing, I didn't update my coordinate system. I guess I could go back and update that to make that a little bit more sensical, what we would expect, the kind of the Z-axis, the tool coming down that direction. So now when I go edit my stock and choose round stock, let's use our fixture coordinate system that I just defined. Axis is Z, and perfect. There's our cylinder kind of lined up with our model. Now we have great options here where we can offset, right, certain values, add a little bit up top, add a little bit below. You get more intelligence, and you don't have to deal with this sketch and changing the sketch plane for stock on the bottom and editing, right? It's all contained now here on the CAM side, which is, where that definition of stock really belongs. You don't want to have to, creating sketches is great for SOLIDWORKS to speed up our process and do different things, but if we can avoid it, great. It's one less step. All right, let's jump back over. End conditions now for part perimeter. So this is a feature type that struggled a little bit in the past with, having parametric definitions. Let me double check my SOLIDWORKS CAM options and make sure my part perimeter feature recognition option is turned on. It is. So now if I recognize features or extract machinable features, we get out our features, including the perimeter. And if we edit that now, it's just this small section at the bottom where it says end condition. We used to not have this number box, right? It used to just be bottom of stock, bottom of part, and so on. But now we have more intelligence where we can use offsets from that value, push it down, push it negative as well. Right, so this is good. Having an accurate feature definition is a lot more powerful of a workflow than coming here later and in the operation, like limiting the Z depth or something like that. That's not as parametric of a workflow, though it does work, and it's been the way we've done it for a long time. This is a far better method to define our stock, or define our feature, rather. Defining a feature accurately is really the best workflow. Once again, I can't stress that enough. And this new addition gives us a lot of power, a lot of options to do that in more effective ways. Drill depth intelligence. This is a really cool feature as well. As much parametric linking as we can have, as much, using different parameters to drive intelligence within our toolpaths. Let's take a look at an example of this. We have this whole group here that I'm going to go ahead and generate an operation plan for. Obviously, we get out, kind of our strategy, just a simple center drill and a drill. If I edit this drill, though, we're going to see some new functionality here on the drill tab, on the drill hole parameters tab, rather. You can see these two new icons here, input values. If we click on either of those, right now they are set to input value, meaning we just type in a number. But we now have these other more intelligent options saying, hey, based on the size of the tool or the length of the flute, right? Those are good things to consider when you're doing these types of pecking, right? You can kind of control the depth you're going to based on the diameter of the tool, how stiff it is, right? Or how much flute length you have. Like, do a percentage of the flute length every time you do a pecking routine. So these are cool new enhancements to, drive these hole cutting operations more parametrically. If I change the tool size, right, I'm going to get an intelligent update of the peck amounts based on that tool size, right? And this is something CAMWORKS and SOLIDWORKS CAM does in a lot of other places. Hey, go a step over percentage based on the tool. Therefore, if the tool changes, I'm always stepping over 40-45% of that tool diameter. Now they've just kind of extended that logic, right, to drilling operations as well. And lastly, we have this very important option. It kind of did this in the background in a way, though it wasn't very explicit and not as robust as it could have been or really should be to protect people from crashing their part or having an issue after they change their stock. So very simple idea here. If I just generate operation plan for all of these, now that we've got all of our operations out, right, these operations are based on stock, right? The toolpath is going based on certain stock definitions. That's certainly true of this face mill, for instance. If I head back to my stock manager and update that, so we can come into our Z dimension. Let's add a little bit of extra material in the Z direction. As soon as I hit check mark, this new window pops up, and this is kind of the whole thing right here. This whole enhancement is letting you know which of these items are going to be affected by that new stock change, that new stock update, right? And I don't think I have to explain why that's important, right? The face mill needs to understand where the new stock location is. It needs to add more passes. Your retract and clearance and rapid planes all need to take into account these new stock definitions. So we say yes. If we go look at the face mill now, we can obviously see it's taking care of all of that additional stock that we added to the top of our part here. So that does it for the SOLIDWORKS CAM 2021 enhancements, but still a small list, but a very effective list. A lot of good opportunity for saving a part or just Don't have to go that dire, but even just saving time programming and not crashing your part out, crashing a tool bit out on the machine. All right, we're going to go back 1 year, and we're going to stay in the SOLIDWORKS CAM package, because this is, once again, something that everyone on this call, as long as you're on a valid SOLIDWORKS subscription, you should have access to this tool. And it's good to go back and review these. All right, so save, restore, TechDB layout. So if we jump into the tech database real quick. Shouldn't have closed it earlier, but no biggie, quick enough to open. If we go to settings, it's this option right here under the customize settings kind of box right here. Save settings and restore settings. So this isn't saving your tech database. The real way to save a tech database is, I mean, it's always saved. It's this file right here. This folder location is where our tech database is located. And if you have this old tech database file and you move into a newer version of the software, you would use this import database option. That'll pull in all of your strategies, tools, and machines. What this save settings and restore settings about is how you configure your different areas of the software to look, like the organization of these columns and display methods of the different sections. So still nice to have to be able to reorient this data in an effective way, something that's meaningful to you, and then be able to save that, not have to customize that every time. So that's a nice little enhancement. Similar to the save and restore or copy settings wizard from just regular SOLIDWORKS, right? Probing routines. So this was a big enhancement as well. Might have to show that in CAM. I'm not sure why it's not. I don't know why my options grayed out. That's not a big deal. I can show you more of that when we get to CAMWORKS. I'll make sure to show you guys that. We also have tab cutting now. So let's jump over to a different part. So I can show you some of this. We're going to extract machinable features. Tab cutting is very useful for people on routers and things like that, where you don't necessarily want the part to break away from stock, right? You want to leave a little bit of material behind, joining the stock and kind of the final part. Break away later. So if we go into the contour mill here, it's just a check mark down here in the contour tab, right? This is a kind of a function that's specific to the contour. And so we find it here on the contour tab in the bottom right corner. I can turn on tab cutting. If we jump into the settings, you can see which features we're applying to, size of the tabs to be specified, number of tabs. You kind of get previews, right? Out here in your display window, we can see some of those tab locations where they would be created. And actually, before I run this, it might be better to update my stock. I thought I did. I guess I closed the part without saving it. Let's go in here and add some extra stock in Z and X, simply because those are the ones increasing my part perimeter. I want to see here's that same message again, alerting us we've updated the stock. So now if we go edit this contour mill, we actually have a little bit more material left to hang on to right around the outside of the part. Actually, let me double check that this perimeter open pocket, there we go, make sure it updates. So now, tab cutting settings. Things we want to be aware of are things like lead in, lead out. I might do a feed over just for example's sake, just so we can clearly see these tabs formed in a second. So you can see where these kind of final tool paths, these final depth of cuts, right? They're jumping over those tab locations where they were specified and leaving a little bit of material connected to the outside. Let's run a quick simulation and kind of see the final result of that. Right, so I'm not saying these are the greatest tabs, right? Obviously, we would tweak our settings, make sure we're leaving enough material behind in order to keep this part still firmly secured, right, for purposes of breaking away later. But all of that information, excuse me. Sorry about that, had a quick cough. All of these different parameters about size, right, length, and things like that can all be customized and updated here. As always, guys, if you have any questions, be sure to type them in. No pressure, though. You got my email address, and this presentation is going to... I am recording it now, and we will upload it for future use, so... All right. Tapered multi-point tool. So this is just a nice addition to be able to use certain types of tools, to be able to simulate those types of tools correctly within the software, make sure we're getting accurate results. So if we go look at this current tool on this drill operation, I'm going to go to my tool crib, add a tool, see if we can't find a... I know this is a drill operation. It's not a threading operation, but we're just trying to explore the fact that with a multi-point thread tool, if I choose one of those and select it... Oh, I can't use it for this, of course. Let's head back. Bump this up to thread. Let's regenerate. Now we got a tapping. So now if we go into our tool crib and use that, there it is, our multi-point thread. Huh. The main endpoint here, guys, is when we choose a multi-point thread tool, there will be a new parameter box listed here in the tool dimensions where we can specify a taper angle, right? And nothing really changes other than the fact that if we're cutting a tapered hole, we'll have an accurate tool definition that will give us a good simulation result and show us what we truly expect to see out of a multi-point tool. See if I can get that one working in a moment as well. I'm not sure why. Maybe we need to be on thread milling. We'll try one more time. There it is, single point thread mill. So if we go to our tool crib, there we go. And like I said, there's our taper angle. I swear I wasn't lying to you. But here's that taper angle where, as you can see, when I type in like 15 degrees, for instance, we zoom in on our tool preview. Right, we have more accurate tool definition for these types of tools and features now. And lastly, the UPG became universally available to all of our customers. So let me see if I can't pull that up real quick. It's on my desktop. Why is it not showing me? All right, I guess I got to close my PowerPoint down. No biggie. You guys get to see my somewhat organized desktop here. But the Universal Post Generator, the UPG, is what you would use to create posts. That's a service we offer at GoEngineer as well, and this tool can be somewhat intimidating to get into. And we have a lot of experts on our side that really know a lot of different machines and different things to consider. So this is the same tool we use and you could use as well. But once again, that's a good discussion to have if you're considering, and we can talk about the pros and cons of that. But this is now available to all users. See if I can't get my PowerPoint started here again. Of course, it wants to display on the wrong screen, but we'll switch that up here in a moment. Cool. All right. Yeah, so we'll jump into probing routines in the CAMWORKS software. I wasn't sure why it was grayed out, but we'll cover that. But let's move back a year to CAMWORKS 2020 and talk about the full-blown enhancements. If you're a full-blown CAMWORKS user, what would be the enhancements for you? And so we have now a very powerful tool, edge recognition for chamfers. So a lot of people don't model chamfers or edge breaks in their model. Some do. It's always kind of been like a little bit of a gray area of best way to do it and most effective way to do it. But this came along and really settled the fight and made it very clear how we should be doing edge chamfers. So I believe I have 2020 open. I do. Let's jump on to that same bracket arm part. And if we look at our CAMWORKS options and take a look at our extract machinable feature options, making sure we know what we're recognizing, it's this last checkbox here. This is CAMWORKS, not SOLIDWORKS CAM, CAMWORKS only. 2020. Curve features for chamfering. We have a couple options concerning that as well, right? Like the max difference between faces, right? Where we would chamfer, where we would want these edges created. We can also just say no, planar only. Like don't try to do it between, crazy curvy cuts and things like that. So with that option turned on, if I run extract machinable features, I think maybe this is the part where I had adjusted my stock. Not in 2021. Let's double check our stock real quick. Okay, it's even on top, no problem. So looking through our feature lists here on both mill part setup 7 and 10, well, 1 and 2, I've done this part several times, right? It keeps iterating up on me. But notice towards the end of each of those feature lists, like in this first one, we have a curve feature, right, created. And you can see it's starting at the top of the part, and the blue lines we kind of see in the middle are like the depth of the features, though for chamfering, that depth is very arbitrary. I could make it 1,000,000 inches down. It's really just going to focus on the top feature edge here. You can see it's done the part perimeter. It's done each of those 3 pockets. And it's also done this large hole over here, right? It's actually not a hole, and that's the reason it created those edge features. It's actually identified as a circular pocket. And if you guys aren't aware, how do I make a hole turn into a circular pocket? It's this option right here. When we recognize holes, if a hole is bigger than 1 inch, it then gets, turned into a circular pocket feature. Right? And so this hole is bigger than 1 inch. That's why it became a circular pocket. That's why this curve feature for the edge break has also been applied to it, but not to these counterbore holes, for instance. Right? Holes themselves usually have some kind of spot drill or countersink come in and clean them up. It's part of their routine, so they're not included. And we have a similar curve feature for all those same kind of items, just on this opposite side. Let's right-click on the curve feature here and just use that edge break strategy. Obviously, it comes out with a contour mill using a countersunk tool. Generate toolpath. Exactly what we expect to see, right? You can understand how if the 45-degree tool, we can actually just show it. Why not? If that 45-degree tool was placed, right, bottom dead center on that toolpath, we see that nice edge break going all the way around. And it's real easy to jump in and modify some of these different values for sizes and clearances and things like that. All right. Threeaxis mill operation contain area preview. So whenever we're applying multi-surface features, and that's kind of what three-axis milling means to us in CAMWORKS. So CAMWORKS or SOLIDWORKS CAM will say 2.5-axis feature. That means I draw a 2D sketch, right? A sketch on a plane or a face and give it a constant depth. That's 2.5-axis. As soon as we start talking 3-axis, we're typically talking about curvy surfaces. Surfaces we identify to cut, right? We're not drawing sketches and giving them depths. We're identifying surfaces. So I have that example here on a part I tend to use quite a bit, and if any of you have had a presentation from me before, it's very likely you've seen this part. So all I've done so far is identify a multi-surface feature, and I've clicked all those faces highlighted in that nice bright blue that we see. So those are all the surfaces I intend to cut. So a problem with multi-surface features very often is what's the inside of this shape and what's the outside? Well, that terminology and that mode of thinking doesn't make a lot of sense. When I tell a tool to come hit this surface right here, I'm kind of turning on and off. The tool says, okay, I'm going to cut that surface, but what's the inside and the outside of your shape? Should I go to the left of that surface and try to compensate to the left? Or should I go to the right of this surface and try to compensate that way? This is stuff we typically deal with when it comes to multi-surface features. They don't have an inside like a pocket does and an outside like a pocket does, or a inside and outside like a boss does, or any of the other 2.5-axis features. So when we jump over to look at the operation parameters, all I've done is applied this area clearance on it. If I were to generate toolpath on that right now, the toolpath might go everywhere. It might find a lot of freedom, right? It doesn't have an inside and an outside. It's just like, hey, I'm going to go hit those surfaces from every side, from every angle. I'm just going to just go for it. Well, we can control that here with under the Advanced tab. And this existed in older softwares. It just didn't have this nice preview that made it very clear what you're trying to accomplish. So the reason the toolpath wants to go everywhere is the automatic contain area by default, and these defaults can be updated. Of course, you can save the strategy and change this and change your defaults. But this method is stock. And so when I click on that and just kind of click back on stock, my window out here, my display window updates. And we see that yellow kind of contain area is everywhere. And it's like, no, I don't want that. That's not, that's giving the tool too much freedom. And I might just back up a second here. If we go Tools, CAMWORKS, Options, or SOLIDWORKS CAM, Options, and we go under Update, this method has to be turned on. So there's this Threeaxis toolpath generation method. If you've been using CAMWORKS a long time and you like it, you might stick with previous method and what you're used to. But even if you've been using it a long time, I still highly recommend you change to this advanced method, even if it takes a little bit of a learning. It takes you a little bit to learn, and we're not talking a long time. We're talking, it's pretty quick. There's not a lot different. But if you're a new user, you want to make sure this is turned on. Starting this advanced method gives you a lot more of these great graphics previews in the operation parameters window, right? Including this idea we're talking about right now. Right, so there's stock, and it's going to give the tool too much freedom. It's going to try to skirt its way outside it's going to try to cut those surfaces from the outside as well, not just inside. But we could update that to bounding box. Gets a little bit smaller, kind of an XY bounding box. But the real solution here would obviously just be all silhouettes. The silhouettes of our tool's perspective. So something I often say in training is be the tool. Right, like look down, look at the perspective of the tool. Right, when we define a multi-surface feature, we say all displayed sometimes. Well, look from the perspective of the tool, everything that's displayed to the tool. In this case, when we talk about silhouettes, imagine the tool was a light bulb. What shadow would the surfaces I clicked cast? What shadow would show up back here on the ground behind the part if I'm the tool looking at it shining a light? Right? Guys keep having a cough there. But if we're shining a light, right, once again, what shadow will be cast? That's this all silhouettes option. We also have outer silhouettes. If you had, for instance, I filled in this hole right here, this circular surface right here, didn't truly exist. The only reason I filled it in is I want my toolpath to be smooth across it. But if I hadn't included that, I could say outer silhouettes, and that would be included even if I hadn't created it, right? It's taking the outer shape of my silhouettes and making that the full silhouette. So something I'm typically, whenever I'm doing this, set it to all silhouettes. Toolpath on center makes sense. The toolpath is allowed to bring the center of itself to the edges of our part. And that makes sense for a kind of internal cavity like this. If you were doing more of a core, right, kind of the other half of a mold, the positive side, the side that kind of sticks out a little bit, I like to go with past, right? Give the tool a little bit of wiggle room, and it honestly wouldn't be too bad to apply here either. But it gives that tool a little bit more wiggle room, right? The full tool diameter is now allowed to go past kind of the original edge. That's what this extra offset value is. But if you want to type in something more specifically, and there's up to, right? The tool has to compensate right away from the wall. But on center is pretty typical, and then maybe just typing in a small offset to give the tool a little bit of wiggle room and make sure it cleans up that top edge entirely. I like that. It seems small, but it used to be a pain not knowing exactly what you were setting. Maybe your feature was defined wrong. You have to go back and analyze that. Is that not including the correct silhouette? And this all saves you a lot of time because some of these toolpaths can take a long time to generate. But now with this preview, you have a better, you can better anticipate what to expect, right, before you hit this preview button and maybe wait around. You know, in this case, maybe 10 or 15 seconds. In some cases, it gets far more complicated, right? You might be waiting 30 seconds or a minute for toolpath to generate, only to realize this stuff was set incorrectly. So it's good to test that stuff, know about it before you hit that generate toolpath button and possibly be sitting around for a little bit. And sitting around a little bit for not good results, for inadequate results. Another one, there's been a couple other enhancements, and I'm happy to share any of the documents with anybody that's interested to see the fuller list. But these are really the main takeaways. A lot of the other stuff is a little bit more ticky-tacky, smaller stuff that isn't as easy to grab onto and say, hey, I can use that. These are the highlights. And this last one, the multi-axis mill clearance plane preview. Very similar to the last option we just showed. I actually did set this machine up, as you can notice, as a 5-axis machine. Not that this part requires it, but just for example's sake, it could be cut using 5-axis. You could get pretty good finish results in there if you did that. But if we edit this multi-axis mill, which is our 4 and 5-axis toolpath, it can also do 3. But if we edit that, and as one of the more robust toolpaths, one of the larger toolpaths, more complicated options, it does take, it's why it's good to have these options, because it can, if you make a mistake, you could be waiting a while for code to generate that you didn't, you found out wasn't good. So this clearance plane preview is now a nice option. Kind of shows us where that clearance plane is, right, where it would be present based on the origin. A really popular one for 4 and 5 axis would be cylinders. Right, so imagine I had this guy chucked up in a rotary, just a 4-axis, right? Kind of the rotary on this side clamped onto it. Well, this would be perfect. You kind of line up this clearance plane with that rotary axis, right? You get this nice preview now to make sure you're doing everything correctly and setting yourself up for success. So, all right. Those are it for the main enhancements there. As always, just keep asking questions if you guys have any. We also are offering something called an AE mentoring session. You can sign up for that at GoEngineer.com under support. If you have more questions about exactly how to do that, once again, my email's right here. Feel free to email me. And now we're going to do something a little unorthodox, which is open a PowerPoint I've looked at for not very long. Where did I put that? Oh, it's in my downloads folder. And look at some of the 2021 enhancements for CAMWORKS. And I've looked at some of it. We'll work our way through it. Like I said, not going to be the most polished part of this presentation. This is from Mark Bissell, very knowledgeable guy over at formerly Geometric, now HCL. The CAMWORKS software manufacturers. So let's take a look at a few of these enhancements. Yep, so just typical enhancements in all the packages. So let's see here. Oh yeah, that's right. Recognizing counterbore holes now. Right, so there is something in SOLIDWORKS CAM and CAMWORKS already called multi-stepped holes. And this kind of brings this into that same category where, see how it's kind of breaking up a whole series into kind of 3 different features or 2 different features, right? By breaking those up, it gives us better control over the toolpaths and where they're applied, what geometry exactly gets hit by what toolpath. So good enhancement there. Let's see here for stock. Oh, this is an enhancement that's in SOLIDWORKS CAM as well, right? We had the option to create our own new custom stock sizes and use those with one click. Same idea here. We now have the option to do cylindrical stock within milling without the need to draw a sketch. This update of CAM data when we change the stock, I reviewed that as well. That's in SOLIDWORKS CAM. Pec amount also in SOLIDWORKS CAM. More advanced probing cycles now. So if you have kind of a multi-axis probe and things like that, you can add those options in as well. Some default options, right? If anybody uses kind of touch-off routines on their controller, I can speak from experience for like host controllers, right? There's kind of canned routines about how it goes in and touches off, and some of those very common ones are the 3-point boss or bore, right? It just kind of has a set routine. You show it where the whole center is. It plunges, touches off, gives you center. Those are now included as kind of standard routines in our library, if you will, our library of routines for probing. Got more probing parameters. This was a nice thing. Waterfalls tended to be kind of an issue, and when I was doing those multi-surface features and I talked about allowing the tool to go past and things like that, with ball noses, it can see every part of the tool as being able to cut, and that's why it does this kind of waterfall off the side of the part. That's not everyone's interested in that. I tend to agree that this is kind of like the tool's trying to work too hard. Well, now with the waterfall options unchecked, right, we get more of a tangent extension kind of coming off the part. A little bit safer, right? There's probably no need to come down the side of this part with a ball nose, right? It's probably already been hit. If you're doing multi-axis milling, we can now do this spiral swarf milling. So the spiral toolpath is a very nice toolpath. You can even do it in SOLIDWORKS CAM. I'd be happy to show you guys that in a moment. Actually, let's just jump into it before I forget. Wrong folder. I have to have both softwares open right now. And actually, real quick while we're here as well, I mentioned the probe operation I would show. So if we come over here, we can add a probing operation. You can define probe tools, obviously, within the tech database now. And here's that operation parameters, right? So tool, pretty straightforward. Feeds and speeds, obviously, something very slow, right? But refined as you get more comfortable with the probing routine, but no need to take the probe fast. The whole point of the probe is that you're cutting apart safely and accurately, so might as well not rush that particular setup, or that particular step, I should say. So what are we measuring? An X and Y? Are we measuring a Z? Often, we can use these different boxes to say, hey, we're touching off on these faces for X and Y, and it organizes them into appropriate boxes based off your coordinate system. But we're never really touching off on the part, right? We're usually touching off on stock. Well, in some cases, if it's a work in progress, you might be touching off on cut features. But we do have these nice boxes, these options here for choosing the stock extents as well, and being able to choose those to touch off on. Clearance and travels. What are we going to do with this probing data once we're done? We're going to update our work coordinate system, update the G54, right? Whatever it may be. So very nice addition. The more data we can capture in our CAM, in our SOLIDWORKS file, in our CAM data, and the less we have to, remember to do at the machine. That's the worst phrase, right? That's the worst saying that we can think of in CAM. You got to remember to do this. You got to remember to do that. If we can build all that data back into SOLIDWORKS CAM and CAMWORKS, then we're safer, we're more efficient, right? A lot of benefits. And what was I going to show you that I already forgot about? Spiral milling. So even with SOLIDWORKS CAM, our base level option, we only have the Z level finishing pass when it comes to multi-surface features. So I'm going to add that real quick just to show you kind of this spiral idea. We're going to be smart. We're going to jump over here and say all silhouettes, making sure it's not going everywhere. Let's head over to Z level, and right now we're on constant. Let's bump up our cut amount in the interest of generating code quicker. This would not be a very good surface finish, but I just want toolpath to show up quick. Yeah, spaced out a little too much, but it looks good and all. Like there's great toolpath. It's very clean. But look at this transition, right? This transition between Z heights is kind of abrupt. It's literally 90 degrees. It's literally turned as turned it can be from the existing toolpath, right? And it's, if we're going to polish this and stuff later, it might not matter, but you still want it. aim for a better surface finish in general and not have these awkward transitions. So if I come in here and change my cut amount, my cut type from Z level to helical, right? We can specify angles and things like that. If we take a look at this toolpath now, it's not all that different, with the exception of how it kind of transitions between passes. Might even eliminate a couple retract and approaches, right? Because the tool's able to stay down. Yeah, I only have one approach and retract now. And look how this thing really, it goes around once, but then look on the next pass, right? It starts to work itself down ever so slightly. And if we look from the side, you can really see that spiral effect, right? As it kind of zigzags down, right? It looks like a spring almost. So that's a similar idea to this, but in 5-axis milling, right? Just it makes the toolpath easier to create, right? We're not having to try to tweak a bunch of settings to get what we want. We kind of just have one option for that now, a drop down for that. Ooh, some more options, and I apologize if I go through this quick. Like I said, I saw this stuff for the first time an hour or two ago. That's kind of cool, being able to, when you're tilting the tool away or moving away during a gouge protect on a 5-axis operation, you get to minimize that tilting of when it wants to lead in and lead out. It wants to be like, okay, I got to go back to the lead in and lead out options and really follow those exactly. Looks like we can kind of mitigate some of that freedom that the tool might have had and trying to go too wild and on its lead in and lead out. So it's a nice feature. This was a cool one that Mark, the guy from Mark Bissell from HCL and CAMWORKS mentioned to show. It's the ability to do this continuous B-axis turning, being able to move this tool around and right, if this tool didn't have this type of freedom, wouldn't be able to get its, that diamond insert wouldn't be able to hit all of these features, just wouldn't be able to fit its tool in. But with some of this continuous B-axis turning functionality, a lot more advanced tool paths. Sure, so there is a global spline deviation, which if you guys are unfamiliar kind of with what that concept means, let me pull up my most expensive software here. And, right, so if we're cutting a spline, your machine doesn't have axes lined up with that spline, right? Your machine has axes in just two arbitrary directions, right? X and Y, and right, obviously Z as well, but in this case, just looking at X and Y. Well, if the tool is limited to, or the machine is limited to moving the tool in these directions, what you really are cutting, and I'm going to draw this very gross, but it's obviously not as bad as this, right? If you set your spline deviation high, you get something like this, whereas if you go and set that spline deviation smaller, right, you'll start to get more accurate results, but you're always limited to moves, right, in your primary drive directions. So there is an option for spline deviation in the software already. This is all over the place. Nothing new here. Just kind of making sure you guys know about this. Just looks like this new B-axis toolpath is able to take advantage of that as well. So overriding some spindle direction for turning, right? Very important. Probing on mill turn machines. That's a nice enhancement, right? Being able to use your probing cycles on mill turn. Makes sense. Oh, I didn't know about this one. This is a really nice one. Importing and exporting of tool data. So this used to be doable, though a little awkward to work around and do between two CAM softwares. But what really made me go, whoa, right now is the fact that I saw the .csv. Right? Anytime you see .csv, it makes me feel good because I deal in a lot of different softwares with a lot of different customers. CSV is like the foundation of them all, though. Comma-separated values, right? It's an Excel file. The fact that we can put them into CSV really gives us a lot of freedom, whether it's transferring it to another database or even exporting it into an Excel for a setup sheet for people, right? Like there's a lot of stuff you can do with the fact that it's a CSV file. That's cool. Being able to change the sequence of features and operations in the database. Change the operation order. If you can also change the feature conditions, you can have multiple feature conditions that a feature matches in the database. And so, well, which strategy is it going to use? If it matches this one, it matches that. Well, which one is it? It always chooses the first one it finds going down the list. Start at the top of the list and work your way down. And the first one it finds that it matches, it uses. Well, in order to change this stuff in the past, it was really painful. You'd have to like put a dummy one in and change the other one, and then you'd have to change. Now that you can just rearrange them, that's definitely a big enhancement. Post-processor path, we talked about this. This is available in SOLIDWORKS CAM as well. Where are we? Part perimeter feature end condition, we discussed that. Ooh, that's nice. 64 bits feed and speed library. So the feed and speed library is a part of the... Oh, that looks really nice, actually. Like I said, this is the first time I'm seeing some of this stuff too, guys. The feed and speed library is this... It's from a software called MEMS, Micro Estimating Material... I can't remember exactly. But it was a little bit of a clunky software, as powerful as it was. Very useful. Little antiquated, 32-bit. I didn't even know it was 32-bit. Now we have this nice new 64-bit. This interface is, oh God, million times better. Really nice to see. Good enhancement there. I do not know what a Harvey tool is. If anybody knows and wants to throw that into chat, maybe we could speak to it a little bit more. Helical end mills. Not sure what this one's all about, but if you know what Harvey tools are and they're useful to you, it looks like we now have the option to include them as well. Shop floor is a software or a product you guys might not know about. The setup sheets and tool lists out of CAMWORKS are sufficient, right? They're adequate. They're satisfactory. They're not anything special, and they're hard to customize. Shop floor is a very, very affordable product that gives a lot of power to the guys out on the shop floor to... that's why it's called that, right? Excuse me. Gosh, this cough, guys. Sorry. Shop floor is a really powerful product that will allow guys out on the shop floor to be able to open a 3D document, flip it around, analyze the toolpath, know where fixturing's at. It's a really good and very affordable conveyance of information, and gives the guys out on the shop floor a lot of power to analyze something before they throw it on the machine kind of blind, right? They don't have the great software we do up in the office, so... Harvey Tool, thanks to Thomas Dollar here, who mentioned that Harvey Tool is a manufacturer of precision cutting tools based in Massachusetts. So I'm wondering if there's just some kind of partnership there that allows you to import some of these files very quickly into the folder or into the database. It's interesting. Maybe they're just a good standard tool maker and have a lot of standard sizes, and CAMWORKS trusted their library enough to give really quick import options to that, work out a kind of a standard import workflow for them. Yeah, helical. Okay, and so helical tools are, and John Eichmann also chimed in here. Helical tools are what VoluMill is based on. You guys might have heard VoluMill or adaptive clearing or high-speed machining. These are very fast toolpaths, kind of specialized toolpath using a trochoidal toolpath, and it can really, if you're doing a lot of hogging out of material, VoluMill is a very powerful way to clean up all that stuff. And you don't want to just use, you probably want to use a pretty good tool. It's kind of what I'm getting from these guys. I thought most end mills would work for it, but apparently there's probably more optimized tools for it, so it's kind of cool to know. That's cool. Thomas mentioned he also uses the solid carbide spherical cutters for milling some undercuts. It's kind of a cool thing. So yeah, it seems like they're just a real nice tool manufacturer, worked out a standard with CAMWORKS, giving quick import options into the database there. Shop floor, yeah, we talked about shop floor, and that's about all I got for you guys. Time always seems to go way quicker. I was like, I'm only going to have 25 minutes of stuff to show, and I'm double that. So, yeah, cool. John mentioned that the tools from Harvey are pretty cool, so if you guys are interested in a tool manufacturer, maybe give them a quick look in. see what they got to offer, see if it can help you. Thanks to everyone chiming in there for filling in the gaps where I'm not as up in industry. I promise you, I know CAMWORKS and SOLIDWORKS CAM as good as anybody, but some of you guys obviously have some more experience out there in industry and dealing with these different suppliers and things like that. So I really appreciate the input there. But I got nothing else officially for you guys. I'm going to stick around until the end of the hour. If anybody has any questions, chime in. You have my email. Right? There's a lot. If you have anybody with an @GoEngineer email, if you email them with your question, you're going to get paired up with the right person eventually. So we're here to help. Make sure you reach out at any time.